Today we're going to be walking through one of our newest capabilities, causal impact analysis. Before we jump in, I want to quickly describe what we're looking at and the business use case that we're going to be reviewing. So this is a causal graphical model. This graphical model is created alongside organizations in which they have a decision problem or a workflow that they're looking to understand more about. In this example, we're looking at a brand acquisition workflow in which this brand is looking at two platforms, Google Ads as well as Facebook ads, and trying to determine A, how they're impacting web analytics directly through sessions and furthermore through transactions. And then at the end of the entire funnel, we're actually looking at how many orders or transactions are being driven through various pieces of the pipeline. So we can ask a basic upfront question. What is Google Ads causal impact on transactions? And we're actually going to run that here now. What we'll notice is the depiction that we're going to see here in a second is going to show one, the historicals in blue, and then two, it's going to have a red line for our causal impact estimate, and then this gray hazy bar is going to be a rough confidence interval. So if you were to look at this without a causal prediction on here, you might use a linear best fit, or you try to find some line that best fits the data. This would be a correlation-based method. The reason these are difficult and not useful, we're actually going to look at here in a second. And by actually performing the causal modeling at the beginning, describing which nodes impact others, we actually are able to remove the bias that exists in a lot of the data in order to better understand what actually is driving transactions when it comes to Google Ad spend in this example. So interestingly enough, we'll notice a lot of these outliers are actually coming from November, December, so holiday and Black Friday periods in which we'd expect there already is going to be a ton of transactions, so those aren't going to be driven directly through ad spend. The model is actually able to pick that up and not overcorrect for these types of biases. And the reason we can do that is because we include these as nodes on the graph. In another example here, let's take a look at how not only Google Ad spend is driving impressions, people seeing the ad, clicking on the ad, visiting the site, but we also expect this business has modeled it in such a way that, by actually seeing an ad, maybe later that day you directly go to the website of this business and buy a product, and that contributes to their overall transactions. Or maybe you see them later on social media. That social media click-through is actually attributable to uncategorized, so some of these other sections, you make a purchase and so on and so forth. We're actually able to see, what does impressions against direct traffic look like? So as we are able to buy more impressions, what do we expect the resulting causal impact to be for transactions that are attributable to people searching for the website and not directly through Google Ads? And we do see there is a small positive correlation. So roughly with every, looks like million in impressions, there's, for this store, about maybe six or seven more transactions. They have a large ticket item in their business, so 6 to 7 is actually a fair amount of money for this business. This is what we would call marketing crosstalk or lift modeling due to additional marketing channels, whereas typical systems are able to attribute directly what Google Ads does for the business, but they tend to forget what are the tertiary and secondary effects of that marketing channel. To show why a causal model is useful and really necessary, let's actually look at Google Ad spend versus email. In this example, the business spends all their Google Ads money in the US, and they recently kicked off email campaigns in the UK. So the causal model here includes no mechanism for this business to actually drive any email transactions through that are due to Google Ad spend. So you'd imagine traditional approaches would actually see Google Ad spend, see sessions, and say, hey, looks like there's a positive correlation. But there's domain knowledge the human has, and they've actually put into the system in the form of this graphical model that is able to pull out the confounding bias, allowing us to show here that as you spend various amounts, it has no impact on sessions, basically a straight line with some noise and variance. So this is, again, really the key to this graphical approach prior to running any causal impact analysis, is guaranteeing that as you're pulling out variance in the data, you're only pulling out variance that is relevant and correct. In a completely different business, they might actually have a business in which Google ad spend drives impressions, that drives people to click on the emails that they get from email campaigns and transact more often. In those businesses and in those environments, they would draw this line. But in the business that we have modeled here today, that line doesn't exist. And that's one of the, again, core advantages to this modeling approach. If you have any questions, please reach out at athenaintelligence.ai on our contact us page.